Good afternoon, everyone. My name is Amit Kumar Pal, and I'm currently third year undergraduate from Indian Institute of Technology, Kharagpur. And in this session, we are basically going to solve one mock test that is available on the Twitter site. So we'll be taking one topic of mathematics, and we'll be going through some of the questions that we are okay to complete. Okay, and meanwhile, we'll also be discussing some concepts where we are stuck. So they'll basically give you some clear understanding of those topics. So okay, so I'll start with one of the topic that is basically an important topic, and that is line and plane. Basically, in this topic, you must have covered the concept of lines and plane in the 3D geometry, right? So what happened in a 2D geometry, we have basically one single straight line, okay. But what happened in a 3D, in 3D case, we have a line in a space, okay. So you already know how the line in a space is defined. It is basically defined by its direction ratios and directions cosines, okay. And how the plane is defined in the 3D geometry, okay. So like in a 3D geometry, the plane is defined by its normal and any point through which it is passing, okay. And apart from that, we have to carefully observe the concept of perpendicular lines, parallel lines, dot product and cross product, etc. Because these things are involved in the while solving the problem. So that was the thing that I told you beforehand, and that will be used, and rest of the concept will be seen through the questions. Okay, if we start with our question number one, so here it is given that you are given a triangle. Okay, let's say this is some triangle. Okay, and its point are given as follow, like one, and this is beta, and this is b equals to 0, 1 and minus 1, and c is given to 1 0. Okay, so these are basically point given to you, and it is given a median is drawn through this point. Okay, so like this is the center point. Okay, so if I quickly write the coordinate of center point, so it will be average of b and c. Okay, so this will be 2 by 2 comma 1 plus 1 by 2, and this will be minus 1 plus 0 by 2. Okay, so this would be 1 comma 1 comma minus 1 by 2. Okay, so if we talk about the median line, okay, so our median line is AD. Okay, so we have found our median line, and it is given that it is equally inclined with axis. Okay, so but what is mean by equally inclined? It is simply mean that if the direction ratios are 1 1 and 1. Okay, because if it is equally inclined, then its angles with axis would be alpha alpha and alpha, and the direction ratios, or we can say the direction cosines, will be cos alpha and cos alpha. So basically all these will be equal. Okay, so drs. Okay, so we can say these are the drs of the line, and for any line that is passing through 2 point, okay, median AD. Okay, so this is our D point, and drs of median, what we can write about drs of median. Okay, you know that how to write the drs of any line that is passing through 2 points. Okay, so this should be simply equal to coordinate of D minus coordinate of A. Okay, so this becomes equal to 1 minus 1, and this becomes 1 minus alpha, and this becomes minus 1 by 2 minus beta. Okay, so we can say that its drs are 0 and 1 minus alpha and minus 1 by 2 minus beta. Okay, so yeah, so like as we have said earlier, its dr should be in ratio of 1 is to 1 is to 1, but here the first dr is already equal to 0. Okay, so what we can say that this should also be equal to 0, right? So alpha, we can say this is equal to 1, and from here we can say beta is equal to 1 by 2. Okay, minus 1 by 2. Okay, and if we quickly put the values in the expression alpha cube plus 8 beta cube plus 4, then this becomes equal to 1 plus 8 into 1 by 2 whole cube plus 4. Okay, so this is equal to 1 plus 1 plus 4, so this is equal to 6. Okay, and now if we move to our next question part, so our next question is basically we are given two lines. Okay, so we are given some two lines, like let's say we call it r1 equal to 7i plus 8 10j plus 13k plus lambda times of 2i plus 3j plus 4k cap, and r2 is given as 3i plus 5j plus 7k plus mu times I plus 2j plus 3k. Okay, so it is given that these two lines intersect. Okay, so you know that at intersection point their coordinates would be equal. Okay, so since these two lines basically represent the coordinate of any general point. Okay, so if we combine the coordinates in this line, so this would become equal to r1 equal to this is I of 7 plus 2 lambda, and this is j of 10 plus 3 lambda, and this is k of 13 plus 4 lambda. Okay, similarly if we write for r2, so this becomes equal to I of 3 plus mu plus j of 5 plus 2 mu, and this is k of 3 plus this is 7 plus 3 mu. Okay, so this is the case, and now it is given that these two intersect. Okay, so their ijk coordinate would be same. Okay, because at intersection point the point that lies on r2 would also lie on the r1. Okay, so if we equate these coordinate, then this simply becomes equal to 7 plus 2 mu equal to 7 plus 2 lambda. Okay, 7 plus 2 lambda equals to 3 plus mu. So this is equal to 2 lambda minus mu is equal to minus 4. This is our first equation. And if we compare j coordinate as well, so our j becomes equal to 5 plus 2 mu equals to 10 plus 3 lambda. Okay, so this is equal to 3 lambda minus 2 mu equal to minus 5. Okay, so this is our second equation. Okay, so now if we solve these two equations, okay, so let's multiply by 2 in this equation. So this becomes equal to 4 lambda minus 2 mu equals to minus 8. Okay, and if we subtract these two equations, then this equal to minus lambda equals to 3, then lambda equal to minus 3. Okay, and if we put lambda equal to minus 3 in first equation, then this is equal to mu equals to minus 6 plus 4. Okay, this is equal to minus 2. Okay, so we have lambda as a minus 3 and mu equal to minus 2. Okay, and we can verify this as well by putting these values in the k coordinate. Okay, so if we put k these lambda and mu values in the k coordinate, so this is k of 13 minus 12, so this is k of 1, and if we put here, then this is also equal to k of 1. So we can verify that we are getting the correct values of lambda and mu, because Mm, we solved for I and j values. Okay, and we obtained lambda and mu. Okay, and the values that we obtained after solving are also satisfying the k coordinate in the end. Okay, so we are getting correct answer. Okay, and now we have to find the in dot product of a dot 2i minus j plus k cap. Okay, and you can find a vector by putting lambda or mu in the respective equation. So if we put mu value, okay, so if we put mu value in the expression, then this is equal to I plus j plus k vector. Okay, so this is our a vector. Okay, and if we quickly take our dot product, then dot product become equal to 2 minus 1 plus 1. Okay, so this is equal to 2. Okay, so our answer would be 2. Okay, so this is about this part, and if we move to our question number third part. Okay, so this given that the line of intersection of these two planes is parallel to what vector? Okay, so basically you have to find the drs of line of intersection. All right, and if I describe it in a picture way, so let's say this is one plane and this is other plane. Okay, so these two planes are intersecting and this is basically the line of intersection of these two planes. Okay, and basically you have to find the drs of this line. Okay, so what we'll be doing is that let's suppose drs be a, b and c. Okay, so you know that the drs of the planes. Okay, let's say p1 be the first plane and this be p2 plane. Okay, so you know that how to find the drs of a plane from its equation. Okay, there is nothing but this vector itself is the drs of p1. Okay, so drs of the p1 is basically 3, 1, minus 1 and 1. Okay, and drs of p2 are 1, 4 and minus 2. Okay, and you know that whatever be the line of intersection. Okay, okay, so whatever be the line of intersection. Okay, if this is the line of intersection, then we can say that this line is perpendicular to the normal of this plane as well as this line is perpendicular to the normal of this plane. Okay, so basically our line of intersection is normal to the both the normals. Okay, uh, I'll explain it again. Okay, so you know that these drs basically represent the normals drs. Okay, ये जो डीआर है ये इस लाइन इस जो P1 प्लेन की नॉर्मल होगी। ओके, प्लस से ये नॉर्मल होगी तो इसके डीआर रिप्रेजेंट करता है। सिमिलरली P2 के जो डीआर हैं जो P2 की नॉर्मल लाइंस होगी उसके डीआर रिप्रेजेंट कर रहा है। ओके, एंड मैं ये बोल रहा कि जो लाइन ऑफ इंटरसेक्शन होगी। ओके, लाइन ऑफ इंटरसेक्शन के जो भी डीआर होगा ये इसके भी परपेंडिकुलर होगा एज वेल एज इसके भी परपेंडिकुलर होगा। ओके, and you know the condition of perpendicular, the dot product should be 0. Okay, so if we quickly make the dot product equal to 0, then this is equal to 3a minus b plus c equal to 0, and this should be a plus 4b minus 2c equal to 0. Okay, so you are getting these two equations and you know how to solve these equations. Okay, you have to write just simply a b c, and here you have to write the coordinate of 1 4 1 minus 2, and this is 3a, and this is minus 1 4. Okay, like how you solve in a metric way. Okay, under the coefficient of a. Okay, under the variable a you will be writing the coefficients of b and c. Okay, and under the variable b you will be writing the coefficient of c and a. Okay, and under the c you will be writing the coefficient of a and b. Okay, the concept behind writing in this way is simply because the above two equations are homogeneous equation. Okay, and this homogeneous system has basically infinitely many solutions. Okay, and this is the condition for the homogeneous system uh, to be solvable. Okay, or we can say for infinitely many solutions, this is the condition. Okay, so if we okay, so if you solve this equation, then you have to just solve like whatever you solve in the matrix method. Okay, like how you find the determinant of this smaller matrix. Okay, so this would be minus 2 minus 4, and this would be, so this would be a of minus 2, and this would be b of 7, and this would be c of 13. Okay, so you can see that dr should be minus 2, 7 and 13. Okay, in the above method we have just simply solved by the matrix method. Okay, there is nothing else. So you have to just write the values like you are finding the determinant of this smaller matrix. Okay, and similarly for b you are finding the determinant of this smaller matrix, and for c you are finding the determinant of this smaller matrix. Okay, so in this way you have to write the coefficients. Okay, so we can try to find the dr should be minus 2i plus 7j plus 13k cap. Okay, so this should be drs. Okay, So let's say if we move to our next question, that is question number 4. Okay. So this says that the length of perpendicular from 0, 0, to plane. So you are given any general plane ax plus by plus cz plus d equal to 0, and you have to find the perpendicular length from 0, 0. So this is nothing but a d upon under root of a square plus b square plus c square. Okay. And this is given equal to 1 unit. Okay. So this is basically modulus value. Okay. And since d is already greater than 0, so we can simply write this as follow, or we can also write as a square plus b square plus c square equal to d square. Okay, basically we have squared both the side. Okay, we have to find the value of c minus a by b. Okay, so if we write it as follow, like c would be a plus 2d and minus a, and b would be a plus d. Okay, so this is equal to 2d upon a plus d, and we have to find the value of this expression. Okay, so one thing we can do in this question is like simply putting the values of b, c and d in terms of a. Okay, so mm, we have to somehow cancel the unknown terms in this fractional expression. Okay, so let's say we put in this expression the values of a square, this is plus a plus d square, plus this is a plus 2d whole square, and this is equal to a plus 3d whole square. Okay, so this become a square plus a square plus a square plus d square plus 4d square plus 2ad plus 4ad. This is equal to a square plus 9d square plus 6ad. Okay, and this 6ad cancel from both the side, and this one a square also cancelled, so this becomes equal to 2a square is equal to 4d square. Okay, so a square becomes 2d square, so this from here a equal to root 2 times of d. Okay, so if we put the value in the expression 2d of a plus d, then this is equal to 2d of root 2d plus d. Okay, so this becomes 2 of root 2 plus 1. Okay, and if you want to further simplify it, then we can rationalize it, then 2 plus 1 root 2 minus 1, and this is root 2 minus 1. Okay, so this becomes 2 root 2 minus 1. Okay, so this is our final answer. Okay, so I hope you are getting this answer. We haven't done anything special, but we have just solved some algebraic expression, that's all. Okay, there is nothing much new in this question, but just some manipulation and caring about the terms and writing them in appropriate way. That was all. So next, if we go to the question number 5, and then it is given that so basically here you are given plane lx plus 13y plus mz plus n equal to 0. Okay, and this is passing through the intersection of the planes, these two. Okay, two planes के intersection, and is perpendicular to the given plane. Okay, so firstly if we think about the drs of the given plane. Okay, so it is given that this is a plane perpendicular to the 3x minus y minus 2z equal to 4. Okay, so if this is perpendicular, then we can write it 3l minus 13 minus 2n equal to 0. Okay, and for the remaining two planes, like 2x plus 3y minus z plus 1 equal to 0, and x plus y minus 2z plus 3 equal to 0. These are two more plane, and it is given that this P1 is also perpendicular to the line, also passing through the intersection line of this plane. Okay, so if you have to find the drs of the line of intersection of these two planes, then You can do by doing as follow, like this is I, this is the j, and this is k, and this will be 2 1 3 1, and this will be -1 -2. Okay, this is simply definition of the cross product, nothing new. So if we do that, then this is I of -6 plus 1 minus j of -4 plus 1, and this would be k of, so this would be -5i plus 3j minus k cap. Okay, so the line of intersection would be parallel to this line. Okay, so these are basically DRs of the line of intersection. Okay, and our plane is also passing through this line. Okay, we can say that the normal of our plane. Okay, let me clear it with picture. Okay, so this is some line of intersection, and our plane is passing through this line. Okay, and this is our line of intersection. So can we say that the normal of this plane would be perpendicular to this line of intersection? Okay, so if we do in that way, then this Lx plus 13y plus mz plus n line would also be perpendicular to this line. Okay, so you can say that minus of 5l plus 39 minus m is equal to 0. Okay, and we have already obtained one expression in the above line. This is first equation. So this is 3l minus 13 minus 2m. So again, if we solve by that first product definition, then this should be L1 and M. So we have written M here because this we have written 1 here because there is no second variable here. So we are assuming it as to be 1. Okay, and again writing it as follow. Okay, so if we solve this expression, then this is equal to L of -78 minus 13, and this is equal to 1 of -3 minus 10. This is equal to M of 35 minus 65 minus 3 into 39. Okay, and if you compare here, then this is equal to L equal to -91 by -13, and n equal to 65 minus 3 into 39 by -13. Okay, and so from here we can say that L equal to 7 and n equal to -5 plus 9. Okay, so n equal to 4. Okay, so these are values of L and M, and now we are left with our last variable, that is n. Okay, so how to find our n? Okay, so for finding the value of n, we'll be doing some tricky part here, since we know that our plane is passing through these two plane. Okay, our plane is passing through these two plane, 2x plus 3y minus z plus 1 equal to 0, and x plus y minus 2z plus 3 equal to 0. Okay, so we can say that any point that lies on both the planes will also lie on this plane. Okay, because it is passing through the intersection point of these two planes. Okay, so we can assume any general point here. For instance, if we suppose x to be equal to 0, then our expression becomes 3y minus z plus 1 equal to 0, and y minus 2z plus 3 equal to 0. Okay, so if we multiply by 2 in this expression, then this becomes 6y minus 2z plus 3 equal to 0, and this is equal to y minus 2z plus 3 equal to 0. So if we solve this expression, then this is equal to 5y minus 1 equal to 0. So y equal to 1 by 5, and z equal to 3 by 5 plus 1, that is equal to 8 by 5. Okay, so we know that 0 comma 1 by 5 comma 8 by 5 lies on our plane. Okay, so we can put this value in the original equation, that is Lx plus 13y plus mz plus n equal to 0, and by putting that value we can find our n. Okay, so this was a bit lengthy part, but there is another approach. So this was a bit lengthy process by which we solved our question, but there might be some easier question, easier way as well. Like we can think some concept of family of the plane. Okay, so we are given two planes, so we can write any family of plane by p1 plus lambda times of p2 equal to 0. Okay. Okay, so this is the family of the plane. Okay, family of the plane, like any plane that is passing through the intersection of these two planes. Okay, so if we write in that way, then this is equal to 2x plus 3y minus 1 z plus 1 plus lambda times of x plus y minus 2z plus 3 equal to 0. Okay, so this is the family of the plane, and from here we can collect the coefficients of x and y. So this becomes 2 plus lambda times of x, and this is 3 minus 2 lambda times of y plus of minus 1 minus 2 lambda times of z plus 1 plus 3 lambda equal to 0. Okay, so this is basically our family of the plane. Okay, and now we know that our given plane, that is lx plus 13y plus mz plus n equal to 0, this plane would be one of the plane in this expression. Okay, we have to set lambda in this way such that our this plane becomes equal to this plane. Okay, and how will we find the given lambda? Okay, so for that we are given the condition like 3x minus y minus 2z equal to 4. Okay, so this plane is perpendicular to this plane. Okay, these two planes are perpendicular. Okay, so we can simply apply the condition of perpendicularity. So this is equal to 3 times of 2 plus lambda, and this is minus 1 times of 3 minus 2 lambda minus 2 times of minus 1 minus 2 lambda. Okay, so this would be equal to 0. Okay, so we have done nothing but we have just taken the dot product simply. Okay, so this is equal to 6 plus 3 lambda minus 3 plus 2 lambda plus 2 plus 4 lambda, okay, equal to 0. Okay, so this is equal to 9 lambda plus 5 equal to 0. Okay, so lambda equal to 5 minus 5 by 9. Okay. So once we have obtained the value of lambda, we can put this lambda into this expression, and दिस इससे हमें एक पूरी प्लेन की इक्वेशन मिल जाएगी. ओके, एंड उस प्लेन की इक्वेशन को एलएक्स वाली इक्वेशन से इक्वेट करके एल और एम की वैल्यू को मिल जाएगी हमें. ओके, एंड उससे एन की वैल्यू भी हमें मिल जाएगी. उसके लिए कोई नया पॉइंट भी नहीं फाइंड करना पड़ेगा. सो this is another approach by which you can solve this question. Okay, so I just wanted to highlight the point of family of the plane concept here, because it is used in number of times, like whenever it is given, like some plane is passing through the intersection point of another two planes, so you can think about family of the planes concept there. Okay, similarly, like if you see the question number 7, then here also the concept of family of the plane is involved. Okay, it is given that the plane 2x minus y minus 4 equal to 0, and y plus 2z minus 4 equal to 0. Okay, so the plane is basically passing through the line of intersection of these two planes, and line of intersection itself mean that it is one of the family of the plane. Okay, so if we write this in our family of the plane form, then this is equal to, so this is equal to 2x plus y times of minus 1 plus lambda, and plus 2 lambda is z minus 4 lambda minus 4 equal to 0. Okay, and it is given that it is passing through the point 1 comma 1 comma 0. Okay, so if you simply put this value in the plane equation, then this is equal to 2 minus 4 lambda minus 4 equal to 0. Okay, lambda equal to minus 1 by 2. Okay, so we can put lambda equal to minus 1 by 2 in this expression, and this will give our answer. Okay, So for today lecture, we are keeping up to this point, and we'll be seeing further question in the next lecture. Okay. So like some more concept related to planes and lines, or we might jump to some another topic of geometry, let's say circle, and we'll also see some mixed up type of question in the next lecture. And for today, I think this much is enough. Okay.